Since the screw is an important part of the injection molding process, we'll now look at it in greater detail and further explain how it works. Since the general-purpose screw can be used to process many different plastic materials, it is the most common screw found in industry. Other more specialized screw designs exist to run special materials, such as vinyl or thermosetting materials. The screw can be divided into 3 sections or zones. From right to left, the 3 sections of the screw are the feed zone, the transition zone, and the metering zone. These sections consist of 50%, 25%, and 25% of the length of the screw respectively. A term used to specify screws is the length over diameter ratio. This ratio gives an idea of the amount of mixing that will take place. The higher the ratio, the more mixing will occur. General-purpose screws typically have an L over D ratio of 16:1 to 25:1. The compression ratio is the ratio of the volume of material in the metering section to the volume of material in the feed section. This ratio is an indication of how much the material is compressing. Typical compression ratios for general-purpose screws are 1.8:1 to 3.5:1. Plastic pellets enter the screw and barrel in the feed zone, where the flights of the screw are the deepest. The feed zone conveys the plastic to the transition zone, where most of the shearing action takes place. Sometimes the transition zone is called the compression zone. In this zone, the flights of the screw are not deep. This allows the plastic pellets to be compressed between the screw and the barrel. The metering zone will melt any plastic that was not fully melted in the transition zone.